Ninjas, we attack again. Let's do another 7 Caillou challenge. This one's called Array Leaders, Array Series number 3. The instructions say, I didn't go through all those lines, you don't need to. Here we go. An element is a leader if it is greater than the sum of all the elements to its right side. So given an array of integers, find all the leaders in the array. Note that the input will be of size at least 3. It could be a mixture of positive, negative numbers, and zeros. Repetition may occur, and the array that you return will have numbers in the same order as were provided in the original numbers list. So let's see an example. For the array 1, 2, 3, 4, 0, it returns 4 because 4 is the only one. Notice that 4 to its right, it only has one element. It's 0, 4 is greater than 0. But you'll notice that 1 failed because 1 is less than the sum of 2, 3, 4, 0. For the same reason, 2 fails because it is less than the sum of 3, 4, 0, which is 7. That should be clear by now. And then they give you another example if you want to look through that and just make sure it's what you expect to make sure you understand the problem. Go ahead and do that. I think that's pretty clear though. And then here's an example with negative numbers you can check as well, because that will come up. So yeah, go ahead and pause the video and crank your own out, and then we'll walk through a couple solutions. I'm going to start like I normally do and kind of not just go right for the link solution right away. You know, I could rattle off some compound link statement, but I don't think that's necessarily the best for learning purposes. Often when I go through the first solution, I don't even use link at all. I'm going to kind of bend that rule here. I'm assuming we're getting a little more comfortable in the 7 Caillou series, and I'll use it a little bit, but I'm going to kind of still break the problem out in a way that's a little easier to think about than just looking at some long link statement with a bunch of enumerable methods on it. So hopefully you kind of understand what's happening, and then we'll end up at the, the one-liner. So to start, you could do the error checking. They notice that the input should be of size 3 or greater. If you want to add a line that checks numbers.length, that would be worthwhile to do. But first, I am going to iterate over the collection of numbers. And what do we do when we do that? We set up a for loop, or sometimes a for each loop. In this case, I want the index values, so I'm using a regular for loop. I is less than numbers.length, and we'll increment each time by 1. So yeah, sort of what I'm going to do then is look at each number one at a time, compare it against the sum of the rest of the array to the right, and then when I find values where that's the case, I need some kind of container to store them in, right? So for now, I'm going to use a list. Lists are nice because it's okay to change the size of them. They can accommodate that. If I start right with the integer array, which is, that would be nice because it's what I have to return. The problem is that I can't change the size of an array, and I don't know what the size is going to be before I've worked with the input. Remember, they could pass us any array of numbers. So I'm going to start with a list, and then at the end, I'll convert the list to an array. Lists are enumerable, and there's built-in method to do that as we've seen. We call toArray on it. So I'll call mine result. You can name yours whatever you want. Let's initialize it to an empty list, but it's ready to use. Okay, good. So now we're going to start looking at values. We're going to say if numbers, remember we're going to access the element, it'll be 0 to start, right? So that first element, if that's greater than everything to the right, and so here's where we're going to use link a little bit to just get everything to the right. I think that's clear enough and we're ready for that. So numbers, and then we have, before I use the link methods, let's go ahead and bring that in before we get in trouble, right? These enumerables have a skip method, right? That's really nice for just sort of jumping ahead and going over the first n elements that you want to. In our case, we're going to want to skip I plus 1, right? Consider the case where I is 0. We're looking at this number right here. We want to get the next 4. So we want to start at 1, index 1, when we're grabbing the rest. Okay. So with that, with skip, you just tell it where to start. In this case, the first index, and it will just take everything afterwards. So that's nice. We also know that we have this sum method that'll just, remember, skip's going to produce an enumerable collection on its own, and then on that we're just calling sum. So it's going to sum up, in this case, on that first step, it would sum up -1, 29, 3, and 2, right? And we're comparing it. If this statement holds true, then we know, hey, this element is a leader, and it should be added to, well, let's just call this leaders. You know, I like to use meaningful names. Leaders add numbers I. That was a leader, so we're going to add it. And then this will keep processing, right? Then it will go to the next step. I gets bumped up because we have it incrementing by 1. I goes to 1. Now it's on this value. It'll say numbers I is -1. Then we have to compare it against numbers skip. 1 plus 1 is 2. So we're going to start at index 2, 0, 1. Here's index 2. Grab those 3, sum those up. You know, that's -24. We see that -1 is greater than -24. So yeah, it's going to add that value to leaders too. Eventually, though, it'll get to the -29, right? And it won't get added. It'll skip over this. But you can see that will process through for every element in the array. And then finally, we can return leaders. And we said we have a toArray method, right? So we use a little bit of link there, but not so much where it was hard to follow along, I don't think. But let's see if this even works first. Type, oh sure, okay. See if you know what to do. We got to bring in system collections generic for these data structures, right? The list doesn't know what list is. I didn't define it, so it's got to find it somewhere. All right, good. So we look good there. I think this one's easy enough to follow. Now we can go into sort of just writing a compound link statement to achieve the whole thing. I'll comment that out. All right. So what do I want to do? I'm going to return numbers, and remember we have where. That's great for filtering, right? And so our deal here is that we're going to want to filter the original input, filter out all the values that are not leaders, and then we have a result. We can convert it to an array and return it, right? So the question is, what's the expression, what's the lambda you put in here that determines whether something is a leader or not? Well, it's pretty similar to what we had before. I'm going to name our parameter n, because remember, numbers are integers. N's a great variable name for a number, but you can do whatever you want. So at each loop, right, we're going to say numbers skip, just like we did in our loop, right? And nothing changed. One thing before we get too far here, in this case, you may not have known this, but one way to handle this problem, we'd like to have the index, right, for each element as we're working here, right? So you might think, oh, okay, I'll make this index variable here. I can reference it in here, +1. I just gotta, at some point, I gotta increment it. You know, you can do postfix, increment, and then I'll have the index numbers to work with, because that's really helpful for doing the skip part. Well, you're in luck. You don't have to go to those lengths. Let me show you. So where? We've used where before. I'm not sure with the overload, but notice, let me go to the top here. Notice there's an overload. So you got two different ways you can use this. Overloads, it's the same method, but they have different parameters. This lower one filters a sequence of values based on a predicate. Yeah, okay, buddy, same thing as the top. But each element's index is used in the logic of the predicate function. Now that's handy. And you'll notice the func tsource boolean here, we've got func tsource in32 boolean, so that int's probably the index. You can click on that. We'll go down to the example. I'm not telling you not to read that stuff. It's worthwhile to read, but I want you to see this in action. Notice now, instead of just the number or the n like we're using, we expanded our parameter list, right? And where is smart enough to know how to handle the index. It'll start at 0 and increment it every time on its own. So that's really useful. But we have two parameters now. So we're going to add that and leverage this in our problem. So let's copy their format. They had a parameter name for the actual element itself, which should come first, and then index. So now I can refer to this just fine. So anyways, we're back to kind of like we had with the for loop, right? Numbers, skip, index +1, but we need to do something a little bit different. We're also going to tell, actually, I wonder if I have to do that. Yeah, so I'm sorry, thinking aloud there. So let's try a sum, right? Because we want to know the sum. We're comparing it to the value of n. And this whole thing, we want to say if n is greater than this, right? That's our condition. We need the element to be greater than the sum of all the elements to the right. And then finally convert that to an array. Okay. Hopefully I got my parentheses right. Let's just test it. It'll tell us if we're wrong. Okay, good. We got the green. So yeah, you see it looks a lot like this other way, but you know, for a lot of people, if I just write out this to start, it's like, yeah, okay, I kind of see it. You know, you're not going to be able to maybe just rip that out on your own. You know, I want you to understand what's actually happening. So that's why I wanted to kind of step through the for loop, get a little bit of length before we go full one-line madness. So hopefully that was helpful for you. But yeah, we'll run the larger test just to make sure. And we got all of our green. Awesome, we can collect our points. I'm going to clean up here so I'm not sending off commented code. Get rid of some extra white space for my OCD. And then I'll go, well, they're going to make me run it again. That's fine. Submit. And then, yeah, just have a look around, see what other people did, see what new tools you can put in your box there. So that pretty much looks the same as what we did. Again, your variable names don't matter. We used n and index. You can name whatever you like. That's a lot like the other way that we did. For some reason they had to reverse. Okay. But yeah, I'm not seeing anything too different. But look all you want. Hit me up with questions if you have any. Otherwise, I'll see you in the next challenge. Thanks.